Welcome to New Hampshire DOT Statewide CORS Network and NGS Modernization Talk. My name is Steve Ferguson, and I work at the Geodetic Department Survey at New Hampshire DOT. Today, we're going to learn something about GPS. Let's go over an outline of what we're going to be talking about. We have the New Hampshire Statewide CORS Network, do a little introduction, get some of the terminology out of the way, talk about its purpose, come up with ideas of how we can do it, and then just a quick summation of what we talked about. After that, we're going to be talking about the National Geodetic Survey Modernization, what it is, and what the National Geodetic Survey is trying to do with new datums, geoids, state plane coordinates, and the U.S. Survey Book. GPS basics. Now, these are the very, very basics. GPS uses satellites, and satellites orbit the Earth. We all know that. Now, with technology and enough money, you can get the satellites to talk to the instruments on the ground, and that is done by longitude and latitude, and that's translated into coordinates. Now let's think about the usefulness of that. If we can get coordinates anywhere on site without having to set up traditional survey equipment, how useful would that be? It'd be great for designing and building of highways, construction sites, and as we know, construction equipment is using GPS for layouts. I haven't done any of the modeling that runs the construction equipment, but as you know, that stuff's out there. Now, the GNSS-CORS Network, in our instance, we're using SmartNet. This is a setup of what it is, of what we'll be talking about, and we'll get back to this slide after we get through some terminology. GNSS, what you once knew was GPS is now called GNSS. It's Global Navigational Satellite System. The NGSS is made up of several key satellite systems throughout the world. GPS, what we're all used to, is what the Defense Department created, and that's the United States system. In Russia, they use GLONASS. In Europe, they use Galileo. The Chinese have a system all their own as well. All this together is GNSS. So if you're just using satellites from the United States, you're GPSing. If you're using other satellites, you're GNSSing. Some other terms, CORS. CORS is the continuously operating reference stations. It's permanently GNSS receivers and antennas that are continuously collecting GNSS data from the satellites, transmitting that data to a network server. Now remember, CORS, the continuing operating reference stations, is not CORS, C-O-O-R-S, so don't drink and drive. Rover. Rover is the antenna and the data collected that's used in receiving the satellite signals and the base station and from the core stations. This is an example of one that we have at in the Geodetic Department. There's a couple of different terms that describe what it is that's happening. Where you have real-time kinetic is the term to use. That's an observation technique that utilizes a base station and a rover. Usually requires two pieces of equipment in the field. Now, RTN is real-time network. It's a type of RTK that utilizes the rover and the real-time network. It's a single unit in the field. Everything goes right to it. It's post-processed, actually processed before you get it from the CORS station. And that's what CORS is all about. So you're getting all your answers right there in one stick. Now we've used SmartNet, which is a network that's owned by Leica, survey, engineering, and software company. They own CORS stations and servers and a subscription unit. They're the ones, and in any situation, they would be the ones that gather all the information and then send it out to our rovers. So remember that slide we started off with? What is GNSS-CORS Network and SmartNet? Here it is. It's all the satellites in the sky, the CORS stations, which are known positions, constantly sending out signals. All that information is sent into central computer. Numbers are crunched, gets information from the rover. All those numbers are crunched, and it gets sent back out to you in the field. And that's all you have is a rover and a data collector. Now it gives you real time, so you're getting coordinates, X, Y, and Z, right there. Now, a lot of people would be using the CORS network. So you have a network, in theory, that's set up all over the state. And who's going to use that? Just surveyors? No. Engineers can use it for designing, gathering information, because engineers can topo, as you know. Surveyors do topo and boundaries. Construction companies, they're laying out a lot of the construction jobs. They're also doing as-builts, obviously land surveyors, because it's a lot of measurement. GIS professionals. Also, in New Hampshire DOT, in the survey department, we use GPS, GNSS to establish our highways and to get everything on the same state plane coordinate system. Now, much more than that, you have local, state, and federal agencies, resource and economic development, environmental service, fish and game, parks and recs, state police. Anyone who requires precise and accurate X, Y, and Z in the state plane coordinate system on their site. State police does accident surveys. Right now they have robotic total stations or something out there. They could use the satellite technology, the GNSS, and a rover, and getting all the signals. They can have that site shot quicker with less people, and it would be coordinated between other spots in the state. Everything would be on the same datum, X, Y, and Z. So what's all this for? What are we talking CORS network and the purpose? Now, CORS network is all those GPS units that are in the ground that would form a mathematically tight and geometrically sound configuration of accurate and precise stations. So you have a grid, a spider web, a connection between all of them. Now, this will utilize by a minimum of one rover to collect or stake out the positions or data. So in theory, you can go anywhere in the state and be on the state plane coordinate system and be as accurate one part of the state to the other, and consistently so. How many of these CORS stations do we need? And what do we have right now? Right now, we don't have very many. And the Leica Corporation that has SmartNet has a few. But they have decided and talked with us about how many stations it would take to cover the rest of the state. So it's going to take a 13 or 15 more stations in 60-kilometer intervals to cover the state. And let's take a look at the maps. Gives you an idea of what's going on with, oh, we missed one. Boom, boom. So here's the proposed statewide CORS network. Obviously, you see the state of New Hampshire and all these circles. The yellow circles indicate where we'd like to put some CORS stations, and the red, and actually the blue one down here, would be able to be part of the NGS's national program. They only allow a couple in a state our size to be part of it. They don't want all of ours. So that way they can keep tabs on our coordinate system and how things are going. So let's take a look at that a little closer. So as you can see here, we would have CORS stations set up at different spots. Now, out of those spots, you can utilize buildings. Hopefully, we'll be able to utilize some of the DOT garages or state-owned land that we could put the CORS stations, and it gives us a nice tight grid. You also can see the blue stars that go around. Well, that's Vermont and Massachusetts, and they have some in Maine. You can barely see one over there. Now you can utilize those as part of our network. They can get all that math and do their magic. Great, let's start getting our own New Hampshire CORS. And we can build and maintain our own and run it. And that's going to be initial cost of over $1 million. And that doesn't include the operating costs, personnel, or future updates. Now, Maine, Vermont, and Mass, they already have a system. Each one has their own state system that's run by the state. I looked into possibly doing that here, and as you saw, the $1 million price tag. Now there are private companies that can do such a thing, which I alluded to in the SmartNet. Now, why did Vermont, Maine, and Massachusetts have their own? They didn't have an option. So if they were going to have GPS at all, they were going to have to find the money and get it done. Now, New Hampshire's tried for years to get our own CORS network. Luckily, the pace in which we were able to get the money and to get the process going, we've let technology advancement to a point where there are many options. So now we can either build ourselves for X amount or add on to the existing private companies that have their own CORS stations and maintain the setup like other states do. How's that work in this state? Well, we need statewide coverage. It's going to take 13 to 15 more stations. SmartNet, who operates in the state of New Hampshire already, they're looking to expand. And they've given us a proposal, or anyone a proposal, that they would like to partner up with someone, anyone, to do a one-time engineering fee, which is a startup cost of $150,000. Sounds like a lot, but each of the CORS stations cost anywhere from $25,000 to $45,000. So it wouldn't be paying for all of them. It would be paying to get them going. Now, SmartNet would get their people, figure out where to put them. They could put the CORS throughout, do all the hardware, connect everything, get it all working, so that there would be a statewide CORS GNSS network that we all could use, and everyone using it would be on the same state plane coordinate system and the National Spatial Reference Frame. Everybody would be on the same datums. The answers would be consistent and accurate throughout. Let's sum this up. As we know, GNSS and GPS uses satellites. To get accurate positions, you also need some kind of GNSS base station, CORS, and then the processing of that, you can do it in-house, own everything like the neighboring states. In our case, we looked into utilizing a private network and just being a subscriber. So we would be just like any other surveyor, engineer, corporation in the state. We would just rent the time and utilize the end product. No maintenance, no updating, none of that. Hope that gave you an idea of what we're trying to do. NGS modernization. National Geodetic Survey is changing our world as we know it. They're transforming datums, coming up with new datums, new geoids, and new state plane coordinate system. So in this talk, we're going to go over that, talk about the new datums, geoids, state plane coordinate systems, and we'll even talk about the US survey foot. Overview. In 2025, NGS will play a larger presence in our worlds. Benchmark elevations are going to be derived from the satellites. The benchmarks as we know them, they actually move. They get knocked over, they're hard to find. In the past, we've always been under the assumption and played by the ideas that a monument in the ground stays there, if the coordinates that are on there are consistent year after year after year. It's just not the case. The world shifts, ground shifts, these things move. And based on the experience that NGS has and the new technologies, they're able to see that. So why are they going to modernize? They can build a better mousetrap. The technology is advanced, satellites are newer, better, there's more of them. They have gravity advanced measuring techniques. Gravity plays a part into it. They've come up with another mathematical formula of a better center of the earth that is just better math all around. Now they can do this from the experience of back when we started doing benchmarks in the 1800s coming through. As technologies advanced, they're able to see, well, these things move. They move up, down, all around. So to get things consistent, more consistent, and utilize the technology that we have, they've determined that satellites and the systems of GNSS is going to be able to give you a more accurate representation of elevations. Now, one of the things they're going to do in this is change the vertical datums. To improve the National Spatial Reference System, NGS is replaced in the North American datum of 83 and the North American vertical datum of 88 with a new geometric reference frame and geopotential datum of 2022. So again, they're just changing our worlds from what it was to a better mousetrap. Now, in these new reference frames, they're going to be easier to access than the previous ones. Because that is, if you have GPS and GNSS equipment, you're going to be able to be on site and collect that data. Checks. You're going to want to be able to use the monuments that we had used in the past, the benchmarks, as a blunder check, but you're going to be getting such accurate information from the satellites and redundancies that you can get it right on site and not have to traverse or run levels miles to get there. Now, they're also coming up with a transformation tool so that you can convert from the old datums. You've got a job that already exists, and you want to convert back and forth to the new datum, or have to be at the old datum for some reason. Now, the way NGS is doing that is they've come up with a GPS on benchmark campaign. And they're asking us surveyors, engineers, anybody with the ability and the technical know-how to actually get elevations and coordinates on a list of monuments that they've requested. They have taken, the NGS has divvied up all the states, but in New Hampshire, they've divvied them up in 10-kilometer hexagons, where they've made a model of how they can best transform our information. And in those hexagons, they have 1 or 2 benchmarks that they need additional information on. They're trying to get current information too, which is in the last 5 years. So they have criteria for that, which is on their webpage. And at New Hampshire DOT, we will participate in that benchmark, GPS on benchmarks. They're also coming up with a new geoid model. As you know, the Earth is a sphere. It's not an ellipsoid, it's a geoid. It's a potato. Now, they're able to incorporate gravity, all the satellites, the technology, and just get a better idea of a geoid than they had previously. Math is getting better and better. Now, as part of the new geoid and all the modernization, they've also decided to come up with new state plane coordinates for every state. And in 2022, they're going to be switching over from our existing state plane coordinates to a newer system. They're doing that because the change to the center of the Earth model is, in some parts of the country, a significant change. In ours, not so much. But since they're changing everybody's, we're coming up with a brand new one. Here's an example of their computations and their math of the existing state plane coordinate zones. Basically, the green is good, blue is bad. This is how it's set up now. They've proposed a new one. And as you can see in this slide, we have the distortion areas. Green is plus or minus 20 parts per million. And the blue is worse. So we're trying to get it even throughout the state. I can't compare these two without having them side by each. So side by each, we have the current or the old and what we're going to translate into. This is going to give us less distortion throughout the state. Now, talking about measurement, the US survey foot, as we know it, is going to get retired. The US survey foot is a unit of measure that we in New Hampshire use for our foot. A meter is the standard, but we're allowed to use feet in this country. And in New Hampshire and in some other states, they use the US survey foot. Other states use the international foot. What the NGS wants to do is get everybody on the same page, and they're going to the international foot, which is 1 foot equals 0.3048 meters exactly. US survey foot, 1 foot equals 0.048 and a lot of change. This way, everybody's on the same foot, and we can keep things consistent in our change. NGS is just taking this opportunity to get rid of the US survey foot. They had attempted to get rid of it once before, and they missed that opportunity. So now they're trying to do that. So what's all this really mean? Technology and equipment and math, how we use it, it's all just another tool in our toolbox. We went from tapes to transits to theodolites to GPS stations. with base stations. Now we have a GNSS rover with a data collector, and you can get X, Y, and Z corrected right where you stand. And that's the end of my presentation. Thank you. If you have any questions, I'll be glad to try to answer any of the questions you may have. Thank you.